All right, today we're going to talk about functions. Functions are special relations. It's going to relate two variables, two different quantities, but a function has a special quality. So in the past, we solved some stuff with a replacement set. It doesn't really apply here. We looked at relations before. Now we're going to decide these relations are functions. And later, we'll find some function values. That's not this video. But we're going to decide if relations are functions and look at their representations. So function is a new vocabulary term. A discrete function versus a continuous function we'll talk about. We'll talk about the vertical line test to see if a relation is a function on a graph. We'll talk later about function notation. Nonlinear function is exactly what it sounds like. It's not a perfectly straight line. It's a curve or a zigzag or something like that. And let's look at the representations of functions and a definition. A function is a relation in which each element of the domain, every x, is paired with exactly one element from the range, or y. Notice that in my mapping diagram here, my mapping, every x has only one arrow coming off of it. If any of these x's had two arrows coming off of them because the number was repeated in the domain, it would not be a function. A function has to go, every x goes to exactly just one y. Only one arrow coming off of each number in the domain little bubble. Here's a graph. This graph passes the vertical line test. The vertical line test is that if you draw a vertical line anywhere on this graph, straight up and down, vertical, you draw a vertical line anywhere on this coordinate plane, you will only cross that function graph, that blue line, one time. If you touch the blue line or the function graph line more than once, if you hit more than one point on this, it would not be a function, it would just be a relation. So you can see that this is nonlinear. See how it goes up and then curves back down and curves back up. And you can see that anywhere I draw a vertical line, I will only hit that blue line once. Sometimes if you draw it over here, you won't hit it at all. That's just because this function, as you can see, this graph is going to go on continuously as an arrow. Eventually it's going to get that far over. Just way, way off of the little blurb of the graph you see, the little thumbnail. All right, so let's identify. Take a look at this mapping. Every number in the domain has one arrow going to a number in the range. There's no repeated arrows off of the domain. Therefore, that's a function. Here's a table, another representation of a relation. In this case, maybe a function. If I look at my domain, every number in the domain is different. There is no repeated number in the domain. Therefore, yes, that is a function. Take a look at this. Every number in the domain, one arrow. Yes, that is a function. In this table, take a look at the x's, the domain values. 3, 1, 2, 3. The 3 gets repeated. Because the 3 gets repeated, it's going to pair up with two different y values. And that means that relation is not a function. The 3 in the domain is paired with both the 2 and the -1 in the y's for the range. Not a function. Okay, so again, here's your representations of a function. Table with no repeated x's, mapping with no double arrows coming off a domain. Look, these two both of these go to the same range number. That's okay. We'll talk about this equation in another video. Don't worry about that. And the graph, the vertical lines that I draw anywhere on this graph only cross that blue line one time. All right, take a pause if you want, read that problem. They want you to make some different representations of this. So we'll make a table, we'll pair up first period with 352, second period 304, third period 391. There's my table. Okay. You can always pause the video if you need to. We're going to determine a domain and range. Domain is all the period numbers, the x's. The range is all the number of students, the y's. Should be written in order though. That 304 should come first, right? Not a good answer there. Order pairs, just make them into XY coordinates. And then we'll graph them. So here's my order pairs. These really should be in parentheses, not braces. And then the graph looks like that. Okay, vertical line only touches each blue dot one time, does not repeat. Here's that word discrete and continuous. Discrete and continuous graphs determine whether or not you draw a line or if it's just points. Discrete is dots, DD. Discrete is dots. If you just have points on the graph, it's a discrete function. Continuous means you connect those points with a line, like that picture we saw earlier. If you connect it with a line, it's called a continuous. Continuous is connected. If you just remember, discrete is dots, continuous is connected line. That's how you can determine which one it is. We'll talk later about why things are discrete or continuous. Right now, I just want you to know the definition of it. So this is discrete because the points are not connected. All right, take a look at that. Pause if you want. Which table represents the salesman's cars he sold? Table D is the one that matches. Day 1, 5, day 2, 3 cars, and day 3, 8 cars. The other ones, mix the numbers up. We'll talk about that later. Let's look at this one. This graph is diagonal down. This is a linear graph. It's not nonlinear. It's a perfectly straight line. It's a diagonal line, but it's still a straight line. Even if it's diagonal, if it's perfectly straight, it's linear. If I was to draw vertical lines all over this graph, how many times would each vertical line cross that blue? Would any vertical line cross that blue in 2 places? The answer to that is no. So therefore, this graph passes the vertical line test. A vertical line only crosses the graph once and never more than once. So therefore, yes, that is a function. That's your function basics.